I'm going to be walking around, though.
So grab it and...
Okay.
And
I see.
there you go.
Okay, tough act to follow. So we were the prediction and prevention of adverse events group. So I'm going to go through our journey of how we ended up with our prototype. We went through a few different pathways to kind of get there, because just defining the problem can be a little bit difficult. So we started with our individual clusters of problems that we identified, and we broke them up into probably 4 or 5 different clusters. So we started with the issues being data availability and labeled data availability too. So what is truth? Closing the gap between data capture and collections, and just generally, if you want to do anything with the data, you're going to need the data in the first place, and what are the issues that go along with that. And then moving on to actual implementation of these, the technology needed, and how to actually implement these various models in clinical practice, and how do we then move on to adoption and acceptability, right? People need to actually be able to believe the model that you put into place and be willing to understand, or be able to understand why you're saying what you're saying. And then logistics, so bureaucracy, actual personnel to be able to help you with collecting data, cost, and then actual storage of information, and various things like that. What we ended up with was 2 major large divisions, because the last cluster that we had was really more specific clinical problems. So then the question, is a little bit open-ended. What are the problems associated, specific problems with prediction of adverse events? And then the questions that came up were, well, are we trying to predict what are the problems that we're trying to solve in the first place? So that goes to clinical problems. So I'll get there in a second. And then, or is it the problems with actually getting there in the first place? So since we knew that we were going to be ending up with a prototype, we actually elected to go along with choosing a specific clinical problem that we wanted to address. And we came up with things like brain injury, cardiac arrest, acute kidney injury, bed sores. And we ended up choosing that we wanted to focus on predicting neurologic outcome, basically, trying to prevent poor neurologic outcome. Here's our specific question that we had. What are the infrastructure needs to prevent poor neurologic outcomes in the PICU? So that's where we ended up on, and where we decided to focus our prototype on. So we ended up then with the second part, which was the solutions for this. I'm not going to pull it apart, I guess. So the solutions, and we divided that up into 2 different groups: implementation and data and technology. And as you can imagine, there's some overlap between those, right? Especially between technology and implementation. So implementation, we talked about automated feedback systems, we talked about dashboards, and then transparency in the models in order to build trust as well, and some various other things. And then in the data and technology section, we talked about social determinants of health. We talked about continuous monitoring, longitudinal monitoring, real-time feedback, and also more data sources to feed into whatever model we were to build. So we talked about video monitoring, like in all of the rooms, for example, to try and detect neurologic injury. All of this also comes back to another central question that we never really answered, and that was not the point of this, is, again, getting back to truth. How do we define neurologic injury? So this brings us to the prototype that we developed in the end, which was to sort of solve this question of what are the infrastructure needs to prevent poor neurologic outcomes in the PICU. But what we elected to do instead was really more focus on ignoring this part, the infrastructure needs, and really just trying to develop a model to predict poor neurologic outcomes in the PICU, and then identify the infrastructure needs within each of those individual steps to show where we're lacking and where we need to do some work. So we talk about developing a classic model. And we're trying to figure out what our patient population is, right? So that's the first branch point in terms of, are we just going to be focusing on looking at training our model on high-risk patients only and potentially introducing bias, but with the benefit of reduced resource needs? Or do we expand it to all patients and then potentially spend billions of dollars in training whatever model that you're planning to train in the end. So training a model using multimodal inputs, so not just electronic health record data, but demographic data, continuous EEG monitoring, new sensors that maybe we haven't thought of in the past, Philips monitors, whatever you can think of, implementing information on interventions and responses. I think those are the highlights of that. And then training the model, but you have to train the model to a specific outcome, right? You can't just, you have to actually know which patients have neurologic injury or not. So that comes to, are we just looking at data on patients while they're in the PICU or when they're discharged? Or do you need to follow them long term? Now, if you follow them long term, that's the ideal solution. That also leads to cost and resource allocation and dropout as well. All right, so then you train a model, and now you actually want to use it, right? So how do you use it? Do you do software implementation, hardware implementation? Do you have something that's right at the bedside? Do you have something that feeds to a central repository? Something that feeds to a dashboard? Something that gives providers daily risk scores on a dashboard? Or is it just individualized to each individual patient that you have? Do you provide feedback do you do A/B testing at this point? Do you provide this feedback to providers, to only half the providers, and see if there's actual difference in neurologic outcomes? Or do you show it to everybody and then potentially not run into the same IRB issues that you might have with the first one? And then which ways do you notify patients with, notify providers and such? And then actually measuring the outcome in the end. Did you actually make a difference in this patient's life or in some subset of your patients' lives? So that's kind of where we ended up on in terms of our prototype. And then I'm probably going to hand it now off to the rest of my group to see what I missed, because we had a lot of good discussions, and I feel like I missed quite a few things. I can't take this, I guess.
Yeah, I think we, thanks, Serena. I think we really focused on, we need to do a research study to gather this data, follow the patients, see what their outcomes are, and then train a model. And does that model work? Can we develop a model? The implementation stuff is cool, and everybody wants to see that, but until we actually prove that collecting this continuous data of high-risk patients in the ICU can predict their neurologic outcome, we're sort of dead in the water. So that's the first step, and that can be done easy, right? Oh, it's all easy. Conceptually, take 1,000 patients, high-risk patients. I'm biased, I would say take congenital heart disease babies who are at high risk of neurologic injury and neurodevelopmental outcome issues. Study them, collect the data, and then see if we can develop a model. Because apparently the adults have tried it and they can't do it.
Yeah, just one more thing that we discussed that I think it's important for us to remember is we talked about evaluation metrics, right? How do we actually measure that some of these models are actually work and can work? Not only the ROC or the precision and recall, but really what are the true measures, the true metrics that we need to evaluate in order to be able to put this at a point of care. So that was the other component.
I have a question for your group or for anybody else. So say that we develop one of these models, we have enough data to retrospectively train one of these models, and potentially we're sensitive to the fact that this model is probably not generalizable if it's from a single data source. So you've gone through the process of ensuring that it performs well in multiple different settings and whatnot. How do you test this? How do you then deploy this and measure whether it's working or not? I think we're past the point where we just implement this model, click play in the EHR and expect people to do something about it and everything is good, pat ourselves in the back, right? How do you go from this to a trial or a before and after interventional study, a single arm interventional study, or how do you take that step?
So we talked a little bit about, this is a heterogeneous group and there's lots of different types of neurologic injuries. So how could you potentially, once you now have found a way to identify this injury, like then what? One idea we had was that you could use, for example, like neuroprotective strategy. So maybe you have a patient that you identify as high risk to have a neurologic event, and that triggers maybe in your dashboard or on the monitor or whatever, whether you're meeting your metrics for your neuroprotective strategy, for example, or you could trial other interventions like in that sort of in that way, and then follow and see whether you're making any adjustments, any difference in outcome. But we also identified that it's hard. You might have patients who have like a metabolic injury to their brain or an immunologic injury to their brain or an embolic stroke or a hemorrhage. It's such a broad group of patients that would have to be factored into any trial or implementation.
So what you're saying is it you're trying to predict who's a high risk so that you do the right thing only for the high-risk patients and not for the rest? I mean,
Yeah, no, it's a good question. Yeah, we did talk about that, and I think everybody has their favorite patient population that they would, like I would want to do this in ECMO patients. That's no surprise to anybody. And so, we talked about, do you implement this across the board, or do you only do? So one of the ideas the group had was, could you have video monitoring on every patient and use automated analysis by a model of video monitoring to improve the quality of your neurologic exam. And that could be something that you implement across the board because it wouldn't require, the person hours to do that additional monitoring.
So to answer Nelson's question, I think the answer is it's very hard. We've implemented a series of different models throughout the hospital that are predictive analytic models trained on different outcomes, and a lot of lessons learned about implementation that I'd be happy to share, but I think we're still on the, on the part before implementation. In terms of testing after implementation, and the approach we've taken in the PICU is a little bit more of a pre-post, looking at our models are actually for clinical deterioration as opposed to adverse events. So they're trained in two different domains on the outcomes of sepsis and respiratory failure. So we're looking at, specific outcomes related to those as it relates to antibiotic days, as it relates to among patients who develop sepsis, how many of them progress to severe sepsis or septic shock, things like that. On the adult side, what they've done is gone to a randomized controlled trial, which just wrapped up, where you're randomized at the bed level. And that is actually more on an acute care ward level, and they're looking more at sort of outcomes like, length of stay, things like that. And it's sort of modeled to a certain extent on the HERO trial that was done with the heart rate variability monitors in the NICU, trying to demonstrate a mortality benefit in that case. But it's incredibly hard trying to figure out what is your metric that you're going to track for neurologic outcome, is your PCPC score like better for the 2 years? I think it's really, really difficult. And unfortunately, the other lesson learned is the chief nursing officer, the chief quality officer, and the chief medical officer are driven completely by these metrics because they want to, because there's a cost associated with this. And they're also very, very concerned if that, especially for dashboards, if this information is up there, it's in the public domain, families are seeing it, if it's not being responded to, does that expose the hospital to malpractice and things like that? I have no answers. Just yeah.
Well, I think we didn't get to any conclusion either, but we discussed a lot about what metrics would be. What is a poor neurological outcome, right? What we have right now, and that's not really totally right? It's what we have right now, but how do we get to that, to define those? I guess that's by itself is a study. I don't know.
Functional status scale.
So that was a really interesting question. I'd like to ask, if there is an AI decision support tool and it generates a prediction, would you then assume that clinicians would need to obey it and that they should just take it in isolation? Could it not just be like any other event in the ICU? For example, your bedside monitor goes off in alarms. Is that a reason that the chief nursing, folks would ask for why you didn't respond. I'm just curious about, should the algorithm be treated in isolation, or should it be treated as one signal amongst many signals?
Testing. Yeah, so I think we have very much consider this one more piece of information. These are trajectory-based models, so they're really designed more to provide situational awareness. We do have to protocolize it. That the hospital insists there has to be some sort of response protocol. It's not as rigid as a BPA or something like that. I think, though, there is this perception issue, right? So we have a nursing PhD student whose project is going to be interviewing families that have spent time in the NICU and PICU and have sort of seen these metrics. It's called Comet. It looks like a comet, and you see, oh, that's my kid, and now why is their score going up? Their score could be going up for a whole host of reasons, even though it was trained on one outcome. That's another issue. Is like you train a model on one outcome. Guess what? It can go up for a whole. You can be having opioid benzo withdrawal and look a lot like sepsis. And so, yes, I think we think of it as another piece of information. The hospital is very worried about the exposure.
And I would say that the legal cases are one case, and the event happened, and you go backwards, and this was alarming for 12 hours. You didn't do anything about it. It's not a case control. It alarmed and everybody else that never had an event, right? That's not how lawyers work. I think Ramesh was.
Yeah, and just building on the previous point, I think the distinction is that even though we, as in the data field or in the outcomes research field, may view it as one element, just like a monitor beeping, I think just given the public perception of AI, and this came up this morning in Dr. Dean's presentation, where people just believe what's out there, right? You take a sound bite, and that's the truth. So I think the point there is that I think from a hospital administration, and this has come up in many venues over the years, is I don't think people are saying you to follow it blindly, but people have to provide an affirmative reason why you did not follow it. So the bar is higher than just a cardiorespiratory monitor beeping, which beeps all the time and you let it go. Here, there's something more that has to be done. That's the only point. And it just raises the burden, I think.
We need two mics, I think.
So I have a question about the CHLA work that's been done with the networks and training models and explainability and so forth. My perception from reading the papers is this is a retrospective data set that you already have, and you build the model with an internal validation and test data set so that you have no legal exposure to prospective monitoring of a model that you don't respond to. That's pretty accurate, I think. The question I have is, have we taken any of those models and tried to test those models on other institutions in the virtual PICU, again with their retrospective data so that there's no liability, to see if they generalize outside of CHLA? And isn't that sort of a corollary to Barry's question that we have to prove we can develop a model? We have to prove that we can develop a model, and if you pay to train it, that it will be generalizable to other places. And so you're showing me PDC, and that's going to be the answer to everything. Is that right? And so that answers that question. The comment I would make, though, to the earlier question about an alarm going off that relates to an artificial intelligence neural network model, is that right now I turn off the alarm if I know what it means and I'm ignoring it because it's meaningless. But if you have a neural network with 10,000 weights in it and you can't tell me why it went off, you're going to have a lot of trouble convincing me to use that as another additional data point.
If you have a model that makes a terrible prediction and you go and look at the patient and he survives, you never look at the model again. If he dies, you trust it for the rest of your life. That's how bad we are.
Anybody that hasn't made a comment yet, please raise your hand. A little bit of the introverts speaking up, or the not excessive extroverts.
Well, I can answer the question about VPQ data. Yes, we do have a retrospective data set. There has been some work in VPICU on some multi-site studies to validate with other sites. In general, we can't use VPS because VPS doesn't have the same level of granularity that we use in our internal data set, but the PDC will. So it will give us the opportunity to do more of that external validation than we are able to do right now. Melissa, do you want to talk about? Because I think more tomorrow. There we go.
Just one challenge to going back to the comment about noise in the data and signal to noise ratio is that I think we need to move away from this idea that we're going to build a model, even if we use data from 20 sites, that's going to perform great on the next 20 sites. I just don't think that it's going to happen. I just have sort of this feeling that that will never be the case. Each model will need to be adapted to its own context. And maybe there's clusters, the same way that heterogeneity of patients, there's heterogeneity of ICUs. Maybe there's clusters, there's phenotypes of ICUs that are similar. And maybe the Seattle model works well with the nationwide model because there are two phenotypes of ICU that are very similar patient populations and practice patterns and whatnot. And maybe we can build a model that's good for those two sites. But it's not going to translate to every single site. And I think it's either clusters of sites that have very similar historic performance that is comparable, or maybe it's like Harbor whatever thing with the other, the two ICUs that the same group manages for. I don't know what the other second one you guys have, but I think that's we need to bear that in mind.
That's problematic in terms of the perennial overfitting question.
Yeah.
And so if you're saying you can train a model and it's not going to generalize outside of one or two institutions, and you've got to make a model for each institution, all you've got is 20 or 30 overfit models.
Well, so it is a problem that we need to overcome. So one thing I would mention though is there is ways of doing transportability of models that is not just you start from scratch, but you start from a source of truth that then gets local. They call this localization, local tuning, which avoids a little bit of the overfitting because it's already constrained by the original models. Maybe you train a model on 20 sites that has a lot of signal and a bunch of noise, and then you localize it to the one additional site where you sort of adapt to the noise of that site. I mean, things like how often people are measuring blood pressures, how tolerant their nurses are to putting erroneous data versus correct data. I don't know, all these nuances of how we collect data that can affect the model.
Yeah, I'm hesitant to wade into an argument between Nelson and Mike, but but I was going to say, I think like one point about it is we act about generalization and overfitting, like that assumes that there's some gold ground truth of physiology, which is the only thing any of these models are going to capture. And I do think that the part that whether we like it or not, there is a truth to something just works better in my PICU because we're used to doing it that way. And it's even with like God's eye view, oracle view of same physiology, we're still going to get a different outcome if we take something from another PICU and try to just apply it directly. And then I was going to make just the concrete example of your point about continued pre-training or whatever variation you want to do on domain adaptation as some kind of concept. But like that's the idea of some of the large language models, right? Like BERT, that even though they do work well and they do generalize to lots of domains, they'll never necessarily generalize to all domains. And I think if we get a data, collaborative that has 20 sites, I think it might generalize to another 20 sites, but it might not generalize to the next. There's going to be 5 outliers that it's still not going to work for. So I think either way, we have to like contend with these problems and build that into whatever we implement.
Yeah, hi. So one of the advantages of the PDC is this idea that we have a lot of different sites where a bunch of data is being collected across the different sites. And what we are able to do when we develop models is validate the models on sites that it was not developed on. And so even if we are not performing as well on site 10 as we are on sites 1 to 9 because the model was developed on sites 1 to 9, what we can do is assess how does our model perform on data that was not trained on, and in this case on sites that it has never seen before. And so I think this is one of the power of just having multi-institutional data. You're able to do these external validations relative to the data that the model has seen before. So yeah, I mean, not guaranteeing that it's going to actually generalize super well, but there is a way to assess it, and that's incredibly powerful for a multi-institutional data set.
So I'm going to switch gears a little bit. And I think one of the things that I don't think we've really talked about a lot is when thinking about the models, like in our predictions, what are we going to do about it, right? If we actually predict something, like what is the intervention going to be? When are we going to do it? Because you can predict everything that you want. And if there's nothing that you're going to do about it, then why waste all this time doing it? And so I think that, to me, has to be one of the things that we really need to consider when thinking of, and again, I say this with the purpose of like, I'm not an expert in prediction models or anything along those lines, but just from a pragmatic standpoint, you can predict something, but what are you going to do?
So what if we find that neonates after heart surgery, if they have more than 3 hours of a MAP less than 40, their incidence of neurologic injury increases exponentially? We can do something about that. Yeah. And we can also, using that same data, show that those patients whose blood pressures dropped and then they were increased, presumably by us, had better outcomes. We could actually use all that data. I mean, it won't be perfect, but we can do something about that.
So I guess as I hear this conversation, I'm wondering if we're at the level we need to be, or is there too much noise in our physiologic data, and do we need to get to biologic data? And you know, I guess I'm wondering if that just adds more noise to our system, or should that be our goal? Is, you know, something like the ancillary study for Prospect, you know, where we're doing a biobank, we're getting to that biologic level, or at least a little closer to the biologic level. Is that something we should insist on? How do you add that data into the rest of this, you know, the data that we have? And is more data necessarily going to generate a better signal for us?
Yeah, this may be obvious to others, so sorry about this question, but I know a comment was made that if we have a training data set on sites 1 to 9 in the PDC network, has a good model fit, then we go to site 10, it does not work as well. So I think my follow-up question is that given that all these data are de-identified, what are we going to do as a result of that? How are we going to retrain that prior data set to enhance the model fit in site 10? I mean, how would we technically do that?
Yeah, I mean, if you want to develop a model that only does well on site 10 and you only have site 10's data, then you could just retrain on site 10, pull like a subset of patients that the model wasn't trained on and redevelop over there. There's a lot of different ways that we could do performance assessments by partitioning data in different ways, depending on the question that you're asking right now. I think actually we're going to talk a little bit more about that tomorrow. We won't go too much into it right now. Yeah.
I would also say, so it's not only about validating retrospectively. I think if you don't prospectively validate, you're going to run into trouble, right? Because in the EHR, the data might show up as the heart rate was 150 at 2 p.m. But maybe the nurse entered that heart rate at 3 p.m. and said that it was 2 p.m. and she was in the room resuscitating the kid and wrote it in a piece of paper and then went back. And so unless you do that, the model's not going to fire until 3 p.m. And the nurse is going to be like, yeah, I was resuscitating the patient for the last hour. Thank you very much for telling me that. All right, so let's go to the next group. Who wants to go? Mike? Okay.